All right, this is Unit 1 review. This is page number 4. I'm going to do numbers 19 through 25 here. So numbers 19 through 21, it says determine if the inverse function exists. If so, find the inverse of each function. So first, let's determine if it does exist. All right, what you're really looking for here is the exponent. Okay, so remember we said anytime it has an even exponent, it's not going to have an inverse function. Everything has an inverse, but just might not be a function. If it's an odd exponent, it will have an inverse. So when I look at this, number 19 is x to the first, okay, number 20 is x to the fifth, and number 21 is x squared. So the first thing I notice is x squared over here. That one is not going to have an inverse function. So this one we're not going to have to go through and find it because the inverse here is not a function. All right, so then what about number 19 and 20? Again, if you're ever confused, you can always look at the graph and figure out the horizontal line test. So number 19 here, that's a square root function. That's going to pass horizontal line test, so there would be an inverse. All right, so how do you find the inverse now that we know there is one here? We're going to switch your x and y. So remember, this is y equals the square root, 3x plus 7. Switch your x and y to be x is equal to the square root, 3y plus 7. Get rid of the square root by squaring both sides. X squared equals 3y plus 7. Subtract your 7, x squared minus 7 equals 3y. Divide by 3, then you end up with y to the negative 1 is equal to x squared minus 7 all over 3. Remember, the y negative 1 signifies that is the inverse there. Number 20, same idea. This is going to be y equals x to the fifth minus 2. All right, switch your x and y. X equals y to the fifth minus 2. Add your 2. X plus 2 equals y to the fifth. Take the fifth root of both sides, so you get the fifth root of x plus 2 is equal to y to the negative 1. Again, y negative 1 signifying it as the inverse. Make sure you realize there is not a plus or minus here. That's only when it's a square root or a fourth root. When it's an even root, this is the fifth root, so you don't need a plus or minus in front there. All right, number 22. Why are the functions f of x equals 4x plus 8 and g of x equals x over 4 minus 2 inverses of each other? So to determine if they're inverses of each other, we're going to have to do f of g and g of x to verify this. So I'm going to do f of g of x. So that's when I take g of x here and I plug it in. So it's going to be 4 times by x over 4 minus 2, and the whole thing plus 8 there. There's an extra parenthesis there. So again, you have 4x plus 8, replacing the x with the x over 4 minus 2. If you distribute this 4, you're going to end up with x minus 8 and then plus 8. Again, distributing the 4, and then that's just x. So far, so good. That's a check mark. All right, we also have to do the g of f. So g of f of x is going to be when I take f of x, the 4x plus 8, plug that in now. So that's 4x plus 8 all over 4 minus 2. Remember, the 4x and the 8 are both over that 4, so I have to reduce to make this x plus 2 minus 2, which is just x. That works out. So the answer here is yes, they are inverses of each other because when you do f of g and g of f, it comes out to be x for both of those. It's not that it's the same, they both have to be x. All right, so 23 and 24 here. 23, state the domain and range of the following relation. Okay, so domain remembers all the x values. So my domain here is going to be negative 1, 3, negative 2. I already used 3, so I don't need to do that again. Notice it called this a relation because the 3 is repeated. So this is not a function. All right, the range here is going to be 2, 10, 20, and 11. All right, and it says, is it a one-to-one function? So no, it's not one-to-one function because it's not a function. All right, so the answer there is no. All right, there are no repeated y values. While I agree with that, it's not a function, so it's not a one-to-one function. If there had not been a repeated value in the domain, then yes, it would have been a one-to-one function since there's no repeats in the range. All right, you have to be careful with that. 24 is the inverse of this function of functions. That's where you use the horizontal line test. So how do you know it's going to be? By using the horizontal line test. Draw a horizontal line through here. That's not the best horizontal line, but draw through your horizontal lines. It's only going to intersect it once. So yes, the inverse of that is going to be a function. Last one, number 25, is very similar to number 3 on this packet. What you're really doing is just doing y equals mx plus b. Right? The difference is I didn't give you the point. Here you actually have to go through and find it. So in 2001, person purchased a car for $25,290. So we're going to make that 1 comma 25,290. That's my first point. The second point, it says here after 11 years. So 11 years after 2001, that's 2012. That's going to be 12, comma. The car is going to need to be replaced. It's going to be expected to be worth $1,200. All right, use this information to write the linear equation. So I have to find our slope here. So I'm going to do my 25,290 minus 1,200 all over 1 minus 12. And again, I'm doing that to find my slope, y minus y, or x minus x. And this comes out to be negative 2,190. So my slope there is negative 2,190 once you reduce that. So that's my m. I need to use that in one of my points, plug it into y equals mx plus b to solve for my b value. So I have 2,290 equals negative 2,190 times by 1 plus b. Add the 2190 to the 25,290 and you get 27,480 equal to your b. So your final answer here is y equals negative 2,190, x plus 27,480 for the final answer.